Greetings and welcome, internet friends. Me and my G amigos are here. Shout out to all you in the whoop whoop. We're talking about triangles today. Good times, good times. So, a triangle is, I'm going to say a triangle is a polygon, which is a multi-sided figure, with how many sides do you think? With 3 sides, yeah. That's pretty good, right there, right there. Although, I do want to point out, notice the word tri suggests the number 3, and it says angle instead. That's fine. It also has, spoiler alert, hey gentlemen on the side of the room, it also has 3 angles, oddly enough. And it's really tough to have a polygon with fewer than 3 sides, because it's not gonna connect. It can't. Like, you can't have a one-sided polygon. You can't have a two-sided polygon. It don't work. Don't diddly work. All right, let's classify triangles by the number of sides. So let's say I've got this triangle here with 3 different side lengths. What would you guys call that? It's a type of triangle, but let's give it a classification. All right, so it has no congruent sides. No congruent sides. And does anyone know the name of that kind of triangle? It's called scalene triangle. Yeah, there you go, there you go. We also have, look at this one right here. What if I have 2 sides congruent? 2 congruent sides. You guys will recognize it when you see it. It is called isosceles. All right, now these ones are being classified by sides. Write this down. Oh, have your notes out, by the way. We will eventually classify by angles as well. Someone said right triangle. Now, as to whether or not this angle is right, a little hard to tell. We'll figure it out later, though. And this triangle has, I'm actually going to double dash these ones for funzo. What if I have 3 congruent symbol sides? All right. Lateral. Yeah, you guys done knew that. All right, how about we classify by the angles time? Are you guys fans of the angles? All right, so these are all less than 90 degrees. Oh, all right, you're looking ahead. If all the angles are less than 90 degrees in a triangle, what am I gonna call that? Acute triangle. Well done, well done. All right. Now, in this case, I've got a mondo angle and then 2 acute angles. Oh, so 1 angle bigger than 90. It just means that one is, yeah, bigger than 90. It's a different triangle. We're just coming up with names for these things is all. And you guys were right. That's an obtuse angle, and oddly enough, we also call it an obtuse triangle now. When this angle is bigger than 90. I'll just call that big. That's true. There can never be 2 obtuse or 3 obtuse angles in a triangle. And we'll see that happen with our later theorems about triangle sum. That'll explain that. So my friend with the candy and the necklaces, this triangle has 1 right angle. So if I have 1 right angle, that's a right triangle. Call it right. So we can classify triangles by side lengths, right, my friends? And we can classify them by angles. Right. Okay, let's keep going. So these are names for things. Good stuff. an equiangular triangle. They didn't give us a picture of it, although it is right here. Has 3 congruent angles. Come on now there, friend. All right, are you getting this? Are you getting this, friends? We'll also call these angles interior. And we will classify this angle as exterior. All right, so you guys have probably heard a lot of this terminology before. So today we're gonna do some theorems. I'm gonna give them to you. We've kind of looked at some GeoGebra animations that might have validated them to us. But tomorrow we'll spend some time actually proving those theorems. I haven't proven it to you. You guys just believed it. So here we go. The Triangle Sum Theorem. I might abbreviate this later as Trisum. Yeah, Trisum Potato Chips was a brand of potato chips where I came from. I did grow up in the whoop whoop. That's accurate. So this is the idea. The sum of the interior angles of a triangle is what? What do those angles all add up to be? 180 degrees. Right? Good stuff there, right, J-Dog? That's right. And tell you what, let's write that out. So I could say measure angle 1 plus measure angle 2 plus the measure angle 3 equals 180. All right, let's take a look at this one. Now, a corollary. We haven't done a corollary yet. So we've used the word postulate, which is used to describe something we accept as true without proof. We've had definitions and properties. We've had theorems, which are proven true, and corollaries are they're like a short step after a theorem that like it's like kind of Isaac Newton's quote, like standing on the shoulder of giants. Right, like he just made discoveries a little bit beyond what other people had already discovered. That's what a corollary is. And the corollary of the Trisum theorem, it's going to be the following. The acute angles of a right triangle so it's a special case. Technically, you could always just use Trisum and never use the corollary. But it can be nice to have a little corollary once in a while, a shortcut, if you will. You know, like when you're Mario Karting and you've got the little shortcut route, you might want to take that once in a while. The acute angles of a right triangle are complementary. Complementary. Does anyone remember what complementary means? Add 290. No worries. All right, so I could say measure angle 4 plus the measure angle 5 equals 90. All right, so now you guys you got that down in your cool geometry spell books. So I have not proven these theorems to you. I've shown you a little bit of an interactive animation from my friend Tim Brzezinski, but we'll prove it tomorrow. Prove it tomorrow. So, example 1. All right, my friends. So here I've got a triangle with some angles in it, and I think this angle, actually those two angles are congruent. Yeah, what kind of triangle is this? It's only got 2 sides congruent. No worries. Isosceles, and it looks like it's acute. I don't think any of those are 90. But using the Trisum theorem, I could say the following. I could have said 8x minus 2 plus 8x minus 2 plus 7x. What do those, all three of these angles add up to? Yep. Hundo ate. All right. Right, so both of those were the same. I technically, instead of writing that twice, I could have also just written 2 parentheses 8x minus 2. I'm fine with either of those. Let's combine some like terms. 8x plus 8x is 16x. No one knows that. Is it 20? I think it's 23. Minus 4 equals 180. Man, good old algebra. Remember that? So 23x equals 184. Divide by what? Yeah, so write this down. If you don't have space to write the orange steps, that's fine. Does this divide evenly? That's a question for my calculator. Oh, it's ocho. So look at that. I can find the value of x doing that. All right. So gee amigos, I can use this. This was using the Trisum theorem. Right? Good old Trisum. And the corollary of that theorem, yes, I could have said in this problem that this plus 90 equals 180. But I could just be like, well, 180 minus that 90-degree angle is just going to be 90. So I'm just going to say this guy and that one, those add up 90. But if you never use the corollary, you'll be fine, right? You can just rest on the Trisum. It'll get you there every time. There, todo de los tiempos. So here we go. 3x plus the 4's x is 7x. Negative 7 plus 6 is minus 1 equals 90. And 1. That's a basketball term. I'm so smart. 7x equals the 91. All right, I just had someone grab a calculator. Thanks. What did you get? All right, x equals the 1, 3. I'm sure basketball reference player number 13 is a thing. Add it in the comments below. All I know is it's Michael Jordan minus 10, which who really even wants that player on your team? So, yeah, so this was the corollary to Trisum. Yeah, I almost never use that one. I don't have to use it in proofs that often. I just kind of, it's technically one step more to use this one, but whatever. Okay. So guys, we also learned about exterior angles. And we said, I'll use the G-reen right here. So guys, this angle 4 right here is an exterior angle. Notice it doesn't go on the entire all the way around right to angle 3. It's kind of like you extend one of those sides and we'll call that the exterior. And so exterior angles have a relationship with what we call the two remote interior angles. So the two non-adjacent interior angles, which would be angles 1 and 2, because notice angle 3 is touching angle 4. And let's see, do I have a good way to phrase this that's not so wordy? The measure of an exterior angle is equal to the sum, right? Meaning I add these two together of the non-adjacent, which we could in parentheses call remote, the far away, the not touchy, That's a reference to Emperor's New Groove. Pretty good movie. There you go. No touchy. Right, there you go. Interior angles. I don't know if you guys had enough space for that one, but sorry. So let's write an equation for that. So I'm going to say measure angle 1 plus the measure angle 2 equals the who now? Measure angle 4. All right, these two added together are going to equal that one. And I showed you a little bit of an animation about that. Maybe it was persuasive, maybe not. Who knows? Who knows? So, all right, it sounds like my students are ready to do this next problem, internet friends. All right. So, yeah, tell me the setup. I agree. Yeah. So this is the exterior angle. It is equal to the sum of the two far away interior angles. Notice these two angles are the furthest away they could be from that exterior angle. Ooh, this is some algebra right here. Bunch of options. What's your first move? Yeah, sure, we could do that. Subtract 2x both sides. Not the only route. You can do it your way, don't you worry. It's not wrong, friend. Yep, the pros and cons to both sides, I agree. You can do it your way. So this is what? 58 is equal to the 2x? Right. So yeah, it depends. Do you want to avoid negatives or do you want to avoid having a variable on the right-hand side? You ate a lot of candy. 25, is this 27? So x equals 27. I didn't calculatorize that, but nope, guys, no. I think it's 29. 29. All right. You just hit the undo button. You just rewind time. What are you talking about? You just write something in pen and you got to erase it. It works. All right. So guys, the new thing we did is this. I gave you a theorem and it's the setup. That's the geometry. The rest is just algebra, right? Right. All right, last two examples. Ooh, this one's a boss fight right there. If you want to blaze on ahead and try these two on your own, you can. The rest of us are going to work through a little bit more methodically. I'm going to write the variable first, but it don't matter. 75 plus x or x plus 75. Come on, my friend Nicholas. Don't be disruptive. All right, so here we go. That's one good one right there. I'm going to speed run this. 75 equals 2x minus 19. I would then add 19 to both sides. So that's going to be 85 minus 1, 94. And then I would divide both sides by 2. So that's 90 divided by 2 is 45. 4 divided by 2 is 2. 47, I believe. And so I get x equals 47. Right, so we're putting these theorems to work. We technically haven't proven these yet, so we don't even know if it's true. We're just doing a bunch of playful geometry and algebra. Yes. Mr. Krabs, I have an idea. Yes. Yeah, I'm a fan of that move. Right there, right there. Yeah, so those three relate. Using which theorem? Yeah, which, by the way, oh, we didn't write that down. It's just eat. Eat is the Oh, guys, I gotta scroll up and write that down right here. Eat. What a great theorem acronym right there. Which actually, by the way, this video is brought to you by Try Some Potato Chips. Eat, try some. Yeah, try some. Bam. Exterior angles theorem. Eat. Oh, I apologize. Yeah, I gotta. My local friend is telling me I've got to have a little bit more explanation sometimes. I might just skip steps. Let's see. Subtract the 13x from both sides. What's that? Negative 5x. You can do it your way. You can go your own. I can't sing anymore because I'll be sued. Copyright infringement, YouTube. You know how it is. Subtract 54 sides. All right, guys. That negative 45. Divide both sides by negative 5. Is x equal to negative 9? So, I think that works. Now, I want to show you a couple routes for this y one. Now, technically, hey, how does this and this angle relate that I just marked in yellow? Vertical angles theorem, they're congruent. So I could have set up one equation by saying this, this triangle, right? I could say all of those add up to 180. Oh, slow, just a minute. Oh, double negative, guys. Oh, good save. My internet, my local friend, I'm sure my internet friends already were going crazy in the comments. Negative divided by negative is positive. Thank you for the save. So guys, look up here. Stop hablamos. I could plug 9 in here and then say that these three angles add to 180. Or, what's another route I could take? Because I could have said y plus 8x plus 3 plus 51 equals 180. That's like a trisum. What's another route I could take? No? What about these two angles? How do these two angles relate? Yeah, using which theorem? LTP, which actually I guess isn't a theorem, right? Hey, my friend Average, you're talking a lot, and I think you're distracting your peers. So I could have said y plus 13x plus 9 equals 180. So either of those would be routes. Both of them would require me to do some substituting. All right, I'm not going to finish solving that, but if you're wondering, the answer is y equals 54. All right, well, thank you for watching, internet friends. Have a great day. Bye-bye.